Hey class. So today we're going to be going over the Algebra 1 review worksheet, and I'm going to be highlighting some of the problems that you'll find on the even numbers. So I'm going to start off with problem 10 on your worksheet. This problem says 4v minus 4v. If you've already done these problems, I suggest that you take out your notebook and wherever you wrote your solutions on loose leaf, just take them out and maybe compare them to my solutions. If you haven't worked these problems out, as always, I suggest you pause the video right after I write the problem and try to solve it yourself, and then play the video after you've finished that. Okay, so now that I've said what I needed to say, let's go ahead and solve this problem. So this number is in the simplify each expression. So again, when it says simplify, we are not looking to solve for anything. We're just looking to combine like terms. So in this example, we have two terms, and they are like terms. So all we're going to do is simply combine these by adding or subtracting their coefficients. In this example, we have 4 minus 4, so we have 0. And that is our answer. That's all there is to that one. So let's move on to number 14, which is a little bit trickier. Okay, so here we have problem 14. I just realized that I had a typo right there. Simplify. Okay, so here we have problem 14, and go ahead and pause it if you haven't solved this. Okay, so at first you may not see why this problem is a little tricky, but let's go through it and talk about it. So the first step that we're going to do is we're going to distribute these to get rid of the parentheses. So the first thing we're going to distribute is the minus 7a, and the second thing that we're going to distribute is the positive a. Okay, so let's highlight this first, distribution first. So when we have negative 7a times 1, we just get a negative 7a. However, the next multiplication is where the trickiness might come up. So we have minus 7a times negative a. So first of all, we have two negatives, so that's going to be a positive when we multiply those two. The second thing is, remember that when we just see a variable, it's understood that its coefficient is 1. So we just have 7 times 1, so we have these 7 right there. Now, this next part is a times a. When we have a times a, just like when we have, I'm going to write it over to the right, 3 times 3, we write this product as 3 squared. We're going to write a times a as a squared as well. So I'm going to finish out the problem by distributing this a, and then afterwards I'll talk about what we just did there a little bit more in detail. So we have a times 8a again, so we get 8a squared, and then we have minus a times 4, so we have minus 4a. So now we combine like terms, and these two terms right here are like terms, the 7a squared and 8a squared, and then we have a negative 7a and a negative 4a that are like terms as well. So I like to write my numbers in a kind of ascending or descending order. So I like to put the squareds before the not squareds, things like that. So that's just personal preference. 7 plus 8 is going to be 15. So that's going to be 15a squared. And negative 7 minus 4 is going to be 11, negative 11a. And that's fully simplified. That is the answer to our problem. Okay, so I said I wanted to make a few notes on what we did when we multiplied the a's, so I'm going to write that over to the side in blue. So just call these notes. Whenever you multiply two variables together, like I said, this is going to be x squared. What we're really doing here is we're adding the values of the exponents. So what I mean by that is really what we have is x to the first power times x to the first power is equal to x to the first power plus, or 1 plus 1, which just so happens to be x squared. We have the same thing happen when we have, x is raised to more than one power. So if we just have an x times an x squared, that's really just saying x to the first power plus 2, so that's equal to x cubed. And if we had x squared times x squared, this would be x to the second power plus 2, which is equal to x to the fourth. So whenever you multiply variables that are raised to a power, and even if they're not necessarily showing a power, it's understood to be 1, just like the coefficient of this a right here, this negative a, is assumed to be 1. We assume the exponent of a variable without a showing exponent to be 1. So yeah, just wanted to highlight that. Okay, on to the next one. Okay, so here we have another problem, number 20, and I picked this one because it had a lot going on in it. So go ahead, pause the video if you haven't solved it yet. Okay, so what we're going to do is look at each side and see what steps that we need to take. So on the left-hand side, we can obviously combine like terms. So we can combine those x's, and we can combine the numbers. So on the right-hand side, excuse me, we see that we have to distribute before we can combine like terms. So we're going to distribute that -7, and we're going to distribute this -2. So let's first do the left-hand side, then the right-hand side. So when we combine a negative x and a positive x, remember that we assume this coefficient is a -1, and this coefficient is a +1, and -1 plus +1 is 0. So we have no x terms left. Then we look at the numbers, and we have +10 minus 6, which is just going to leave a 4. Okay, that's the left-hand side. Let's look to the right-hand side. So on the right-hand side, we have -7 being distributed. So -7 times a -8 times x is going to be a positive, sorry, a positive 56, I believe, because 7 times 7 is 49, plus 7, 56, yeah. The second distribution is -7 times -2, so that's going to be a positive 14. And then we have the -2 being distributed, so -2 times 5 is -10, and -2 times a -9x is going to be a positive 18x. So the left-hand side we're going to leave alone for this next step. The right-hand side we're going to combine like terms. So we combine the x terms and the numbers. So we have 4 on the left-hand side, and then we have 56 plus 18, which is 64. Nope, 74. 74x. And then we have a positive 14 minus a 10, which is going to be a positive 4. Okay, now we have an interesting realization, if you will. So we have a positive 4 on both sides of our equation now. So what does this mean? Well, this means that when we subtract the 4 on the right-hand side to combine our non-x terms on the left-hand side, we're going to see that we're going to have a 4 minus a 4 here, which is going to give us a 0. So don't panic when you see something like this, because this is fine. this is just simply saying that x is equal to 0. So how do we do this? All right, remember that we have the multiplication identity, or the multiplication property of equality, which just tells us that we can divide this side by 74 and divide this side by 74, or multiply by the reciprocal of 74. Either way you want to look at it. Now you may freak out, but don't, because we can't divide by 0, but we can divide 0 by something. So we can take 0 and say, what's 0 divided by 3? The answer is it's always going to be 0. So 0 divided by 74 is equal to 0. And that, in fact, is going to be our solution for x. So it's totally fine if you ever get something like this and you're left with x is equal to 0. Okay, let's go on to our last problem. Here we have our last problem that we're going to go through together. And go ahead and pause the video if you haven't solved it yet. Okay, so just like our last step in the last problem, we're going to be focusing on the multiplication property of equality. And something that I talked about in class on Friday to one of the cohorts was that whenever you see a fraction like 127 over 13, let me just make sure 127 isn't divisible by 13. Okay, it's not. Whenever you see a fraction like this, the multiplication property of equality tells us that we can multiply by this reciprocal on both sides of the equation, and we will get an equivalent equation. How do you find a reciprocal of this fraction? Just flip it. Take what's on the numerator, put it on the denominator, and take the denominator and put it on the numerator. So 13 over 127 is going to be what we multiply both sides by. So you might ask, well, why does this work? Why can I just flip it? And the reason why we can just flip it is because we can take each part of the fraction and look at its reciprocal separately. So we have 1 over 13. Its reciprocal is just 13, because 1 over 13 times 13 is just 1. And then we have 127. Its reciprocal is 1 over 127, because 127 times 1 over 127 is just 1. Well, then we just multiply these two reciprocals, right? And what we get when we do that is 13 over 127, which is just our original fraction flipped. So once we flip this, we have some big multiplication to do on the left-hand side of the equation. So use your calculator for this. 13 times 1,397 is equal to 18,161. So then we have the numerator, 78 times 127, and we have 9,906 is equal to phi. Now, just like last problem, don't freak out if you see a giant fraction like this. What you can do is use your calculator to plug in this fraction. So when you plug in a big fraction like this into your calculator, you're able to actually just hit enter after you type it in, and it'll fully simplify this for you. So go ahead and try to type this into your calculator and see if you get the same simplification I do. When I put it into my calculator, I get negative 11 over 6 is equal to phi. So if you don't get this or don't know how to put a fraction into your calculator, I can show you in class. But if you got this, that's perfect. So that's it for this video. Hope this helped, and I'll see you next time.